Hello. Hello. Ah, there we go. That's the problem. Yep. For some reason, OBS decided to change my sound source. Good evening. Good evening, all. My apologies. There's always something, isn't there? There's always something. Wonderful having you all back. Let's do the scene change thing so you can see. Good evening. This evening's broadcast is brought to you from the Great Barrier Reef. Ooh. I love the Great Barrier Reef. It's a beautiful place. So unfortunately it's dying. So, if anyone ever wants to see the Great Barrier Reef, they should get to it now before human race completely obliterates it. That's a depressing note to start on, isn't it, hey? So, but anyway, thank you for coming. Let's have a look who we've got. Oh, we've got a few people rocked up already. That's awesome. So, as always, remember, we're going to do some security-related computer hacking activities, and hacking without tea is very uncivilized. So make sure you have a cup of tea. Now, today's tea is as you can see on screen, it is just a straight black Assam, straight from T2. I like to have mine quite strong, but I do add a little bit of milk to take the bitterness, although in this light, it looks like there's way too much milk. Trust me, there isn't. So, anyway, grab yourself a cup of tea. Oh, very good. Very good. I should put that over there so I have ready access to it. So, I don't have dark chocolate. It did look like that, but at Wolf, I was looking at the camera at the same time thinking, man, it looks like I'm really tilting it over, but the camera's actually tilted very slightly downwards. So that's why it looked like that. Now, tonight I don't actually have... it is Indian tea, Mugu, correct, and it's very, very nice. Tonight's hacker snack is straight almonds. I'm a big fan of the almonds. I don't always chow down on dark chocolate this time of night, but I have been doing so on stream recently. But tonight we're just going to have nuts. So hopefully you've got your snacks, you've got your tea, you're ready to go. I can see a number of names in the list that were with me on Wednesday last week. I was actually hoping to back up Wednesday last week with this stream a couple of days later, but as you know, the life takes over, and sometimes it's hard to follow through on stuff. But it is what it is. I don't remember a stream where you haven't had dark chocolate. That's probably fair. Maybe my very first one, I would have had tea. I think I'll always have tea. Maybe my first couple of streams I didn't have chocolate. But yeah, dark chocolate is pretty good. So anyway, thank you all for coming along. So the plan for tonight, off the back of the previous session on Wednesday. Hey, we got another follower already. Good. Thanks for following, Noel. So is to follow on from what we were doing on Wednesday. Now we all got to the point where we were able to successfully create threads without the get injected thread program that Jared Atkinson had written was able detecting the thread that we'd injected. There was a couple of things about the whole setup that I wasn't quite comfortable with. So I think we all learned something from that, which is good, me included. But I just want to revisit it a little bit because particularly in one spot where we were debugging the thread preamble code versus the hijacking code, and we were noticing some differences in stack layout and all that sort of thing. And so I got thinking about that, and I reckon that there's definitely a better way of doing it. So I'm going to dive into that just a little bit, and depending on how much time we've got left, we might even try and go and fix up the migration code, which will probably involve a little bit of work and involve us hacking some Ruby stuff on the Metasploit side, because that's the way the migration stuff actually works these days. Migration stubs of code, which are transport specific, are created in Metasploit and sent down the wire on the fly. Okay, so that's what we're going to do. Now, do we have any questions at all about what we finished up with last week, or should we just dive straight in? And can everyone hear the music okay in the background? It's not too loud, etc. I'm going to go with everything's okay, given that there's radio silence in the chat, which is fantastic. All right, so let's get started. Brief summary on the indication that the PS script looks for. We could probably dive into that again, Smash. So get injected thread. Let's dig this up again. So there are a couple of things that Jared's code does in order to determine whether a thread is injected or not. And the key bit is here. You'll notice that through the code, what it does is it loops through the processes, excluding the system level processes, 4 and 0. It opens up each thread in that process. And for each thread, it grabs a thread handle, and then it queries something from each thread. And that value that it's querying is the base address, so the start address for the thread. Now it turns out that's actually stored, I think, in the E thread inside the kernel. So you can't poke it from user land, which is why it's important to start your thread pointing at an area that's not suspicious, because you kind of can't muck with it unless you've got kernel level access over. At least that's my understanding. So once we've got that, we go and we query it. And then the two attributes that must sort of be applied, I should say the main attribute that should be applied to that area of memory is this mem image flag. Now mem image indicates that that area of memory was basically mapped from an image section that was loaded off disk when the PE was mapped to memory. Okay, so you can see here that there's this epic if statement which does a bunch of stuff and does some checking. And what it's doing is it's saying, if it is a mem image area of memory, then we're just going to exclude it. So what that's saying is if the base address of the thread is marked as mem image, then we're going to assume that it's okay. So that's basically what we abused when we did what we did on Wednesday. Okay? So that is a very, very brief summary of what it is that we did. Does that help? Smash? Okay, cool. All right, so with that in mind, we had a working piece of code, but what I've done is I actually had my VMs sitting here set up exactly as they were when I left them. And earlier on today, I updated my NVIDIA graphics drivers on my desktop. And in doing so, that just completely turned off the virtual machines. There was no graceful shutdown or anything. Both of my VMs that you guys are staring at right now just got switched off. So all of my state was lost, which was a little bit upsetting. But it is what it is. Now, so in the short term, what I've done is I've recreated these payloads because, as you can see down the bottom here, my IP address has changed again. So we're now at 151. And I've set up a couple of jobs that are listening on different ports for different payload architectures. And I've got my copying code ready to go for when we rebuild Meterpreter. Okay, so on this side, I have adjusted the code that we were looking at very, very slightly. Now I'll make the text a little bit bigger like I did last time. Hopefully that'll be big enough for you guys. Get rid of all this Team Explorer nonsense, properties nonsense. Okay, so this is where we were playing when we were working last Wednesday. Good evening, Lucas, Zyantix, etc. Thank you very much for joining in on the stream. Sing out if you have any questions or if things don't make sense. So here, what we're doing, I'm going to flick it over to Win32 for now, and I'm going to clean and I'm going to rebuild the solution. And while that's rebuilding, I'm just going to show you the areas of code that I've modified since I last saw you. Right, so while that's building, so what I've done here is I've changed this create thread call back to this particular signature. So this parameter here was originally a pointer to the thread preamble function, and the parameter we were passing in was this thread object. And the thread object is just a chunk of metadata that we pass into the thread, and we use it internally in Meterpreter to make sure that we can keep accounting of the threads appropriately, right? Finally made it to a live stream. Thank you, Lucas. I'm stoked you're here, mate. That's awesome. I hope you have tea. Make sure you have tea. Okay, so what we do, as you can see, we create the thread in a suspended state. And then once that thread's created, we query the thread context. and we ask for all of the context, which gives us all of the registers and a bunch of other nonsense. So what we did when I finished up last time is we basically poked an area of memory on the stack so that we had set the appropriate arguments to the function that we were calling so that it didn't crash. And at the same time, what we did up here was we changed this code so that we have this exit thread return 0. Now, this kind of felt a little bit dirty. And while we were doing it, I was thinking, why are things so different across the two different things that we were doing? So in one case, we were invoking this thread preamble, and we had a debug break in here. And in the other case, we didn't use the thread preamble via the create thread call. Instead, we just basically hijacked those pointers once the thread was created and pointed the current context over to this thread preamble function at that time. And so at that stage, like, there was very, very different behavior because the content of the stack was basically not the same. And that was confusing to me at the time, but I think now I know what's going on. So what I'm going to do is I'm just going to comment this out, and we're going to put return back in there. So that's what the thread preamble function actually looked like when we first started playing with it. Now, what I've got here is once you've got the thread context, I've set a breakpoint in here. And so while we're debugging with WinDBG, we're going to be able to see what I want you guys to see. All right. What I might actually do as well, maybe we can put a debug break here as well. So let's just do that. Quick rebuild. Because then we'll be able to see the context pre and post thread creation. All right. Now this is really interesting and really key when we're looking at the difference between the two. So we're not so much going to dive into the get injected thread stuff because we know we've been able to bypass that just by kicking the threads off based on this technique. So if we know that we can kick threads off in exactly this manner, then we're going to assume that the get injected thread stuff works. And then if we decide that we've got time and we dive into the migration stuff, we'll actually do the testing like we did before. Okay. Elite Mocker, good evening to you, my friend. Thank you for joining in. We are covering a little bit of a redux of what we did on Wednesday last week, and we're going to try a nicer/cleaner way of creating threads in memory, injected threads in memory that aren't as easy to differentiate from non-injected threads. So we're just trying to be a little more surreptitious with what we're doing. Okay. Now, we've got our listener running. We need to copy our DLLs over. Okay, so at this point, let's fire up WinDBG. You're very welcome, mate. No problem at all. Fire up WinDBG. Let's go to stream payload. So this is 32-bit payload. Kicking it off, and I'm going to hit F5 to run. And hopefully we'll hit a breakpoint. Here we go. Now, I'm going to step out of this function call. And you'll see, where are we? We are currently in that call dword pointer right there. That was our debug breakpoint call, I believe. But what I really want you to have a look at is, hang on, where are we? Are we in the right spot? Executing, here we go. Oh, I must have removed some debug messages. Have I? Oh no, that's still legit. I haven't changed that. So we should be able to see. Ah! Yeah, right. So I need to step over the next function call because that's going to give us the thread context there. So let's just go over the next function. Okay. Now have a look at this. The debug output here says the get thread context succeeded and the stack is here and EIP is here. Okay, now because we've kicked off the thread and we've given it thread preamble, at this point, what I was expecting to see was that EIP was pointing at thread preamble, but clearly that's not the case because that looks to be a kernel, sorry, like a system library address rather than the address of of a library that, or an address inside the PE that we're running. So if we have a look at this, if we type UU of this address, you can see that it's actually right at the start of a function called RTL user thread start. So that's really interesting. And check out the stack. So if we look at the stack value over here, you'll see the stack is clean. There's just nothing there. Okay. So this is what we were seeing when we pointed our thread context straight at thread preamble after the thread was created. We had nothing here. Now, if I hit F5 and we run, we should hit a breakpoint again, which we have. And this breakpoint here is the one that's inside our thread preamble function, just up here. Okay, so thread preamble is executing, thread context is this pointer. Okay, so now this is interesting because at this point you can see that we actually have meaningful values on the stack. Hang on, let me show you. ESP. So there you go. All of the stuff that we expect to see is here, right? We've got this RTL user thread start stuff like we were expecting, you know, and everything goes off the way that we would expect. Now, when we changed this before, and we chose a function somewhere in kernel 32, and we said, let's create our thread and point it to somewhere in kernel 32. And we're going to hijack it at the point that it's suspended, and we're just going to change EIP, and we're just going to point it to a different error, and off we go. And we ended up with crashes. And that's because we didn't have any of this nonsense sitting here ready to go. So in order to sort that problem out, we chucked stuff in the stack. And then when it exited, and when the thread exited, it bailed because, you know, we hadn't actually done all of this other wonderful stuff in here, like RTL user thread start does. So that's why we can continue to run this and everything will work absolutely fine. So this is where I really started to think, okay, well maybe we can try and emulate the normal behavior by changing where we're pointing our thread start function to. OJ, quick off-topic question if okay. Thoughts on Ghidra? Have you tried it yet? You're right, that is off-topic, mate, and I'm happy to talk about that at the end of the stream. But for now, I'm just going to try and focus on what we're doing, so don't think I'm fobbing you off. I'm just going to stay on track and push through what it is that I'm aiming to push through. And for those people who want to hang around at the end and have a chat about that, I'd be happy to have a chat about that too. I hope that's okay. Cool, thanks, dude. All right, so bearing in mind, every single thread that we start, regardless of what we set the thread preamble to, sorry, the thread entry point function to, we end up inside RTL thread user start, like we saw before. So let's go back to my UU call. This is where we land, okay? We always come into RTL user thread start, right? Now, I thought, okay, well, what are the assumptions that are made at the point that RTL user thread start happens, right? So what I decided to do was this. So instead of passing in thread preamble and thread, what I'm going to do, I'm just going to duplicate that. And I'm going to chuck in a couple of values here that can stand out. So let's go dword pointer OX. Now that's a 64-bit value, and it's casted to a dword pointer, which on 32-bit is just a 41414141. I'm going to do the same, excuse me, here. And I'm going to change 1 to 2. Okay, so we've... Oh, that's annoying. Did you see that? It changed the whole line. So let's do this. There you go. How's that for cheating? Okay. So the first two parameters that I'm passing in are just 41414141 and 42404042. That's the first parameter is the entry point, and the second parameter is the value that we are passing to that function once we've invoked it. So what I'm going to do is we're going to get back to this debug breakpoint. In fact, I'm going to chuck another one immediately afterwards because I want to actually get to the output message as well. In fact, I might just get rid of this one. So let's rebuild that, and let's just have a look at where those values are stored. Actually, yeah, let's do that. Oops, what have I got here? LP. I've got to cast this to an LP thread start routine. That's annoying. There we go. Compiler errors, always good. What have I done here? Create thread parameter mismatch. Maybe this needs to be LP void. LP void. Probably needs to be LP void. There we go. All right, so for the thread start, like where I want the thread to be invoked, that's going to be 41414141. And the value that we're going to give that function call is 40404042. Now, I did it this way so that when we compile this in 32-bit, we get 32-bit A's and B's. And then when we recompile in 64-bit, we'll get the full A's and full B's for a 64-bit version. Okay, hopefully that makes sense to you guys. Now we've copied our DLLs over, and let's restart WinDBG. Okay, so we've hit our first breakpoint. Get thread context succeeded. ESP is here and EIP is here. Now we'll just check again. We are definitely at RTL user thread start. Okay. Now, at this point, let's just have a look at. So what I'm going to do, I'm going to set a breakpoint here at NTDLL RTL user thread start. Okay. And then I'm going to let it run. Okay, so you can see here that we've broken right at the start. And what I wanted to do at this point was just sort of have a look at the context around RTL thread start, RTL user thread start. So the big things that I think I want you to focus on here are EAX and EBX. Now, EAX clearly contains the control value that we passed in first, and EBX contains the value that we passed in second. So, bearing in mind that the RTL user thread start function clearly expects those two values to be in EAX and EBX, at least on Windows 10. And this is one of the things that I'm going to have to think about on other platforms, because this may not work on a different platform, which is what I was concerned about last time we had the chat. So you can see EAX contains one value and EBX contains the other. Now, what we did when we did this on Wednesday, we kind of we kludged it a little bit and we poked some values in memory and off she went. So what I would like to do is actually try and replicate this RTL user thread start behavior. Okay. And what I want to be able to do is, going back to our code, instead of passing in the thread preamble here and then a reference to the thread here, what I'm keen to give it is a pointer to RTL thread start. And we don't really care about the value, I guess, that we've passed in. Because if we do that, then we know that we can let the RTL thread start function actually continue to run, and it will do all the accounting stuff that we want it to do anyway. We've just got to make sure that the values that it's expecting to see in EAX and EBX, at least on 32-bit, are correct. So what we need to do is, if we can get a pointer to RTL user thread start, we point that create thread call at that function, and then create it suspended, and then as soon as the thread's kicked off, we can just stop it because it's suspended, and then we can change the value in here of this function pointer and point it to our thread preamble, which is up here. Are you guys following? Am I describing that very well? So I'm effectively saying we can fake call RTL thread user start a second time, or even the first time, by giving it the values after we've suspended it, if that makes sense. Maybe it'll become a bit clearer when I step through it. So rather than messing with the IP, we mess with the AX. Yeah, exactly that. So we're going to point it to the thing that it would have been pointed to anyway. And then once that thread has been created, we're just going to say, actually, I don't want you to kick off RTL user thread start. I want you to do that thing just over there. And then everything kind of functions exactly as you would expect, right? So I'm going to leave that there just so that you can see what I mean. And so what we need is we need a reference to an entry point. And I'm going to leave this value in here just as a filler, okay? So what we will need is an LP, hang on, what was it? LP thread start routine. Thread start routine, our entry point is going to be LP thread start routine. We're going to get the proc address of the function that is RTL user thread start. Let me just make sure that's correct. RTL user thread start, and it's in NTDLL, right? Oops. So we need to get this out of NTDLL, so we can go get module handle NTDLL. I should call that get module handle A, so that we don't have any issues with wide character strings versus non-wide character strings. So that should give us the function that we want to invoke. And at the point that this is created, we should be able to stall the thread here. And in this case, I'm going to stick this breakpoint back here. And I'm going to do this thread context dot EAX equals, let's go D word. We'll just cast that to a D word, what we're about to give it. And we want that to be the thread preamble function. Now, given, I'm assuming that what we're going to see is because this parameter here needs to point to the thread, the thread context that we're passing in, I should be able to change that to thread. Okay? Typo and NTDLL. You're right. Thank you. Who is that? Wormair. Thank you, sir. Oh, ma'am. Thank you, my friend. I appreciate that. Where you said you can't rely on the registers used for passing the values, is this because it's a native API? Does this happen with Win30 API across other OSs? That's a really good question. And the short answer is I don't know. I think it's fair to say that there could be some really implementation specific things, but without actually debugging this on various versions of Windows, I can't actually give a definitive answer. I'm sure there's people out there like Juru or Tavis, Alex Ionescu, Mark Razinovic, you know, those kind of people who know the internals of this stuff up the wazoo and can probably answer that question very quickly. But unfortunately, I am not one of those people, and I would need to go and investigate. Okay, so is this making sense? Are you guys following what I'm aiming to do here? So I've got a debug breakpoint here so that we can see what EAX is at the point that the thread is invoked. And then we're going to set the thread context, and we'll have another breakpoint set after the fact. Now we can probably get rid of this breakpoint, but I'll leave it there anyway for now. Okay, back to our. Hey, what's the topic? Buffer overflows. Virax. No, we're not doing buffer overflows, mate. We're doing some fairly rudimentary bypassing of a utility that attempts to determine whether a thread is injected into memory or not. That's the crux of it. We did that on Wednesday last week, but today we're just trying to refine it a little bit, keep it a little classier. Yeah, it's pretty fun. Hey, okay, so here's our first breakpoint. Let's step out of that and let's have a look at, where are we? Here we go. So EIP is here. So again, let's just check to make sure that's legit. Yep. So that is RTL thread start. Now what I'm going to do is I'm going to set a breakpoint here again. EP. And let's let that run. Now this is our second breakpoint. I actually don't know why I've set this because we're not going to see it anyway. But at this point we should have set EAX to the updated value, which should point to the thread preamble. Now we don't actually know where the thread preamble is, do we? Because I haven't actually outputted it. And that's something that I should probably do. Barney of the Rubble, greetings to you, sir. Okay, so we've hit RTL user thread start. That means that the thread has actually been resumed. Okay? Now, check out EAX. This you can see here is create process thread, right? This value here is the thread context. We can see that EBX does contain the value. Now EAX contains 99 blah blah blah. Let's see what that looks like. Now this is well within our function sort of memory space based on what we saw before. So that probably is our thread preamble. So if I hit F5, hopefully we can step out of this function, and this should be our thread preamble, right? Does that seem legit to you? Now our stack, according to here, let's have a look at this. Right, so these actually look like they contain things that we want them to contain. What happens if we just carry on running? Check this out. We've come back into RTL user thread start. So what happens now if we let this run? We've got a crash. Access violation. And that would be, why is that? EAX is null. What is the UU command? The UU command basically says unassemble the address that we give it. So for example, you can say UUNT DLL bang RTL user thread start, and it will just do the first, number of lines. You can do exactly the same thing with UF, and it will disassemble the entire function, or it should. There you go, and you can see you can follow branches and all that sort of stuff, which is pretty cool. So there's a bunch. U basically means unassemble. That's what the U means. At least that's my understanding of it. Okay, so we've got something kind of quirky going on. It's not the kind of behavior that I was expecting. Ooh, we have yet another follower. Who's that? For Auto, thank you for following, mate. Nice to have you on board. We've got 40 people watching. That's very nice. Okay, so we set the thread context EAX to the thread preamble, and the reason that we want to do that is so that we kick off the thread in the right spot, right? But for some reason, that's not doing what I was expecting it to do. Now, why would that be? I'm wondering if the reason... Oh, here we go. Now, when we looked at the stack before, 30FF0. Let me see. 0 minus 30. Okay, so we have got all the stuff in here that we would expect to see, except for one thing. Hello, 3Kilix. Thank you for joining in. I think this is probably because the thread has actually finished executing, and we're back in this scenario here where we actually don't want to return at this point. We need to bail out. We need to forcefully exit the current thread. All right, so let's just, for now, I'm gonna get rid of the debug breakpoints. Yeah, Morvi, unfortunately there is a huge delay for some reason. I remember it depends on Twitch settings or something, but back in the day it actually used to be 15 seconds for the chat to appear, or I should say 15 seconds for the content to appear to be in line with the chat. But yeah, I don't know whether that's any different. I was under the impression that Twitch had changed something fairly recently, and that the chats were much more in line with what was going on. So there wasn't so much of a delay between what was appearing on stream and what was actually happening at the other end, if that makes sense. Yeah, I'm sorry I can't help you with your buffering issues there, my friend. I had that issue back in the day when I was on ADSL, but thankfully now I'm on fiber to the premises. I don't actually have that problem. Okay, so what I'm going to do now is, once I've copied these DLLs over, I'm going to do it again. rerun this. Now I'm just going to let it run this time and see what happens. That's looking pretty good, hey? Okay, so that looks a little bit better. We've really only munged one value, and we're kind of hard coding our stuff to RTL user. Now, part of the reason why I kind of like this is not only are we pointing our function entry point for our thread to a known location that has the mem image flag. The big thing for me is this. If people decide to get smarter and go, hey, whereabouts is that entry point, and is that entry point actually where you would expect it to be, they're going to note that the thread that's kicking off is kicking off in RTL user thread, or thread user, or whatever it's called, thread start. So to me, it smells just a little more surreptitious. It's something that if you were analyzing it at the top level and you saw that that's where it was kicking off, then it might be a little less suspicious compared to other options. Hey, Menz, thanks for coming in, buddy. So that's pretty good. I'm quite happy with that. Right, so what I'm going to do now, let's leave that as is. But this time we're going to go to 64-bit. Which means I've got to clean and rebuild. Sorry for the delay on this. Now, one of the things that I don't know at this point is how this behaves in 64-bit and where the parameters go. So I'm going to set a breakpoint just here. debug break. So that we can... Actually, we probably don't need to put a debug break there, but I'm going to do it anyway. And then I'm going to put this debug break back in. Because what I'd like to see... oh, actually, no, I don't need one there either. I need to set the breakpoint to RTL user thread start once things have kicked off. You will talk about Gitter at the end, but it's not a debugger. That's correct. That is correct. It has a debugging function to it. Pretty good idea. Gitter doesn't have a debugger at the moment. Yep, I think that's accurate. Yeah, the free decompiler and the fact that, the code windows stay in sync and whatnot is actually pretty fantastic. I haven't dived deep into it, but we are going to talk about that at the end. Does anyone have any questions about what we're currently doing and whether that actually makes sense, and why the rationale behind trying to emulate this behavior this way, it seems legit? I think, to me, this is the kind of thing that would do a better job of remaining undercover compared to other options, which is why I like it. And we're not munging the stack, we're only munging a register at this point, so it'd be nice. It'd be nice if we could actually have this working across different platforms, which I don't know whether we'll get around to doing that this stream, but it is what it is. Okay. I'd be keen to get a sort of mini show of hands. How many of you folks have basically come along for the first time and stumbled on this? And did you come on this just through the science and tech section of Twitch, or did you find it on Twitter, or did you? How did you get here? I know there's a bunch of people who have come in a number of times before, and people I know personally who like for some reason to listen to me drone on about this thing. But I'm keen to know how the wider audience got here. Signal. Yes, I do ping some people who I know. I enjoy having people on stream, particularly people that I know who can chime in, and it's good to have people that I know on stream, because if I make a mistake or if I'm lost or something, then I know they're the kind of people that can jump in and give me some help and offer advice or whatever. And that encourages other people to talk as well. So, For Auto was Science and Tech, Morvi was Twitter, email alerts. Oh, winning. Bull was Twitter as well. Pretty sure Lucas was Twitter too. First time came across Twitter from Winter Heidi. Oh yeah, nice one. She is a gem. Winter Heidi is a gem. First time live. Work in AU Sec industry is small, and people I know you. Okay, yeah, man. The InfoSec industry is very, very small, and in Australia it's even smaller. Yes, I just noticed Stephen is missing. Science and Tech. Cool. Okay, that's awesome. So there's 41 people here. There are a bunch of names who I haven't seen before. So for those people who are new, I'm really delighted to have you here. For those wondering, behind me, this is the Great Barrier Reef, representing my home location. Great Barrier Reef's actually just a few hours north of where I'm currently sitting. Righto. So this time I'm going to need to copy these 64-bit DLLs over, and I'm going to need, I can't use the 32-bit version of WinDBG, so we're going to need the 64-bit one. Might pin that to the taskbar. Get my theme going on, and let's open payload 64. All right, so let's see. I'm just here because I like someone else programming in the background while I program. I can relate to that, Resin. I can relate to that. Righto, let's hit F5 and see where we get to. Okay, create thread context succeeded. RSP is that. RIP is here. I love the word RIP. RIP. Let's see where this is pointing to. It is pointing to RTL user thread start. Fantastic. So that's doing exactly what we would expect it to do. Let's set a breakpoint there and let her run. Okay, so this is immediately interesting, isn't it? What do we got here? Now, the behavior is already different. We can see that RAX, RCX, and RDX, and R8 and R9 all contain the values that we control. Crazy. Damn, look at that number. Yeah, I know. I'm well aware of that. I am well aware of that get system issue. Won't be fixed anytime soon. Okay, so this is pretty interesting. We did actually, I set a breakpoint at RTL user thread start. I'm not really sure why it didn't actually break. I would have expected it to. Let me just run that again. As soon as we've got the thread concept, so this section of code here matches this bit here. So we've literally just spat this out. And next we're going to do this set thread context. Now we haven't changed anything in the thread context, but RIP here is pointing exactly where we would expect it to, right? RTL use thread start. Let's set the breakpoint and run again. So this is really interesting. So RAX, it's as if we're not actually breaking at this point, but RAX is clearly, RAX is where we're invoking, we're actually pointing our function to. I hope you would control those values you're writing. Yeah, exactly. So clearly RAX is this value here, right? Which is the entry point. Oh yeah, well this, of course, we need to set it to entry point, don't we? That makes me feel like an idiot. So let's get rid of this. So RAX is this LP thread start routine. So we can set this back to entry point, which is where RTL user thread start is. I'm going to put LP void back in here and rebuild that. Now we don't need to, at this point, touch RAX. However, actually, you know what that means? We can probably just do this. If RAX is exactly what we would expect it to be, dword pointer, thread preamble, we just need to modify RAX to point to this thing, assuming that everything else is legit. I mean, that would make sense given what we're seeing, right? So let's do this again. So I'll put that there. So I'm going to rebuild that. I'm going to assume that by poking the pointers to thread preamble into RAX at this point, we will get the same behavior in 64-bit, assuming that the second parameter that we're passing in, which is the thread context, continues to bubble all the way through as expected. Is the training in Brisbane sold out yet, OJ? No, it isn't sold out. I'm really hoping that it will be sold out, though. After so many people have come at me from various angles saying, why is all the great training overseas? It's never in Australia. Thank you for joining, for following the Caker AU. Much appreciated. Yeah, so people over here have been asking about bringing the SpectreOps Blue training here for quite a while, and now that the guys have followed through and making it happen, I would love to see Australia follow through and actually sign up and fill the course up. So that's disappointing so far. I mean, we do have a number of seats sold, but we do still have a number of seats available. So tell your friends, tell your mum, tell everybody, because it is a fantastic course. Righto, let's rerun. Let's see what happens. Okay, get thread context succeeded RSP. RIP is this again, which should be exactly the same. Oops. Yep. For some reason, setting a breakpoint doesn't seem to do anything, right? So what do we got here? We've got another breakpoint that's been set. The exception may be expected and handled. We've got a first chance exception here. Push RSP. Is that because our stack point is not valid? Oh no, that's okay. Access violation. I wonder why. Do I have a link to the training? Yep. Oh, okay. Yep. Thanks, Barney, for sticking that in. Okay, so this isn't doing what I would expect. Let's just have a look at what is going on over here. Now, there's our exception filter, blah, blah, blah. Thread start, thread init chunk. Let's just go back to, sorry. Have we got a breakpoint in here? No, we don't. Thread preamble is executing thread context. Okay, let's see if we got that message. We didn't get that message. Isn't that interesting? Why is that? Why did we not get that? We have updated racks and we've called set thread context, and we didn't get the failure message, so one would assume that that's okay. Just give me a minute. Let's see what's going on here. VPNTDLL. RTL user thread start. Aha. Okay, here we go. That actually happened this time. Ah, maybe that's because that's the pointer that we've given it. Hey Eric, how you going, mate? Now, what do we got here? This must be the invocation of what we've given it, right? Let's have a look what's going on. Move R8 RDX. Okay, so the context of the thread is in R8. RDX, what is RDX? That looks to be 3670. That's RDX is currently a pointer to RTL user thread start. And that's moving that into R8. Move RCX into RDX. RCX is currently a pointer to our thread context, so that'd be the second parameter. Ah, okay. And then we clear out RCX and off we go. All right, that might make a little bit more sense. So that means we need to put... Clearly I was wrong with my usage of racks before. Whoops. Now let's quickly set our breakpoint again. Thread start, run. So we need RDX to contain the pointer to where we go. So I think we need to modify RDX, not RAX. So when the thread is started, we need to modify RDX to point to the thread preamble. Is that what you guys are seeing? Maybe that's the problem. Anyone? Guess it's just me. Come on, build faster. That's what happens when you build inside virtual machines. They take a fair bit of time. Alright, let's copy that over again. Let's restart. Hit the breakpoint. Set the breakpoint on RTL thread start, and let's see what happens here. Call dword pointer. What have I done? I must be missing something. I do need more resources, although I have given my VMs a significant amount of resources already. Okay, so RCX points to somewhere obscure. RDX. I really should output what the thread context is, because I mean, sorry, what thread preamble is, shouldn't I? Let's do that so that we can actually see. Oops. Can't type. CT%. There we go. Thread. Thread preamble is located at. So we just want a dword pointer. This thread preamble. So that's just going to help us at least understand what's in what. I'm still thinking I've got something screwy going on here, so I may just cancel that out as well, because we may be confusing things just a little bit. VM running on SSD? Yeah. No, I haven't got any spinning rust in here. Haven't used spinning rust for ages. In fact, the day that I discovered SSDs, couldn't look back to spinning rust. The speed difference was insane. Okay, thread preamble is 1B C9E0. Let's set our breakpoint again. Run. Okay, RCX points to the thread preamble, which is interesting. Why would that be the case? We haven't specified it here at all, have we? That's just, it's probably just an overhanging thing from a previous function call. Here we go. What do we end up doing? Okay, I'm confused. RDX, which contains a pointer to RTL user thread start, which is basically what we've given it as the function's entry point, right? Move RDX RCX. So we then move. Oh, yeah, okay. Righto. So RCX, which contained a pointer to the thread preamble for some reason. Why is it doing that? We've removed references to it here. The only reason it would be a thing is because of this function call, right? Would have thought recompiling would be faster. I could have sworn it was faster last stream. Maybe it was, but it is what it is, hey. But yeah, this is a little bit confusing. Not gonna lie. You overwritten that point at the start of the function in RDX with the preamble address. Well, when you say you, it's RTL user thread start. That what I want to know is how did it get this reference? Because you can see here thread preamble is located there. So this is a reference to thread preamble. But in the code, the only reference that I've got to thread preamble is here. I have not set it here anymore, it's commented out. So why is it there? I want to know why it's there. It's as if like copying of the binaries or something didn't work. See, that's absolutely fine. Ignore the SSL errors, that's just the Python extension failing to build. I haven't fixed that yet. So that's all fine. Strange. Okay. Yeah, see, it's all just the Python extension, which we don't care about at this point. So let's copy those over again. Let's just make sure. mitserv 64, March 11 now. Yep, that looks legit. Let's do this again. Okay, so we can see thread preamble is in a similar spot. Let's break at thread start and run it again. Now, here we go. That's completely different. Maybe it was just a recompilation problem. Maybe I'm just an idiot. So we should only see entry point, which is the RTO user thread start itself, and thread. And the thread context, according to this, was 44EA, blah, 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 which is an RCX, which is where you would expect it to be. So RDX and RAX, I think, sorry, RAX, I don't think is what we should be looking into. I think we should be leaving RAX alone. And here instead, we should be making sure that RDX is updated to point to thread preamble, and RCX is updated so that it contains. So let's step into this for a minute. That's an unhandled exception as well. It does still just look like RDX is the problem, right? Is it just me? What am I doing wrong, people? What am I missing? Something very important that I'm missing here. Because based on what I'm seeing, user thread start. You know what I'm going to do? I'm just going to quickly reset this back to this, just to be sure that what I'm seeing actually makes sense to me. Happy to receive insights from anyone who's watching. Any ideas from anybody? Okay. I will take your silence as a positive sign. Wait, are we meant to be paying attention? No. Only if you want to. Let's try this again. Let's hit a breakpoint. That's right, I can't set RAX to that because that's... Yeah. So RAX has to point to that. Okay. We did hit this problem before, didn't we? So that entry point has to be... I wonder if... just a sec. Yeah, because we haven't done anything with. Yeah, so the stack is clean at this point. And okay. Yeah, right. I think I might know what the score is. We definitely need to leave that as entry point. And we need to change what I assume is actually I'm going to leave this out. All right, let's play with a couple of ideas. 1, 2, 3, oops. 2, 3, 4, 5, 6, 7, 8. Now I'm pretty sure this is going to break immediately. BX and D. D is the D and C, I guess. And needs to be 3. Oops. Needs to be 4. Let's see what happens when we munge these pointers at this point. Okay. I'm not expecting this to go well, but I'm really hoping to see a breakpoint. When I set a breakpoint to RTL create user thread, I'm really hoping to see that actually happen because we're not modifying RIP. Kind of digging this music tonight. Are you guys enjoying it? Right, let's see. Okay, so we do get to it this time. Now here we go. This is going to stand out way more now. So RDX, what did we set that to again? Oh, we had RDX and RDX. I should have set that. My bad. Yeah, thanks, Null. I just picked up on that. Xiantix, yeah, I'm really happy with tonight's playlist. It's this is a Monstercat Gold, and so far proving to be pretty good value for money, if you ask me. Yeah, it's good. Hey, Moog, I'm digging it. I'm happy. I would be digging this if I was flying solo. It's just nice that you guys are all chiming in and joining me for this. I expected this to be a lot quicker than it is. But hey, let's see what the geo is. Restart, set up breakpoint again, run. Okay, here we go. So by poking, check that out. So we can't muck with RCX because in setting RCX we overwrite the entry point, which we don't want to do. Okay, so let's leave RCX alone. You can see somehow RCX has been copied over to RAX. Sorry, is it C or D? Yeah, it's definitely C. That's kind of crazy. Let's rebuild. We'll leave RCX alone because clearly we're causing some problems by setting RCX. Oh, did that a little bit too early. Copy. Restart. Set a breakpoint. Okay, so we're definitely in here now. So RCX now contains 44444. BX contains 40404042, and R8 contains 444444. Now, for us to continue, what do we want to set? Now, one would assume that if we run, one of these pointers is going to point to an invalid location because this is where the parameters that we've passed in have come in. And the argument that's going to be passed to it, or the first argument that's going to be passed to it, which I assume would be an RCX, which could be wrong, will cause it to break. So check that out. 44444444 is where it's trying to go, which is in RDX and RAX. So that would then make me think that 444, so RDX is what we want thread preamble to be. Yep. And the parameter that it's being given, now what's the first parameter again? I'm pretty sure it's RCX, isn't it? Which is that. Which we haven't poked at all. So wherever that is, we need to somehow munge. Now we're back to where we were before a little bit, weren't we? Let's go back to make sure there's a debug breakpoint in here. It's interesting that 64-bit is causing so many issues. Why is R9 also? Yeah, I don't know. I honestly don't know. I mean, behind the scenes is crap copied sort of all over the place, isn't there? But yeah. We want to leave RCX alone. RDX at the time that we're invoking this should contain thread preamble because that's what we're jumping to. Question is, what's the first parameter and do we need to modify that as well? Which we're about to find out. Okay, restart. Breakpoint. Oops. Hang on a second. Ooh, that's behaved a little better. RTO use the thread start. Go. Right, so let's see. So R8 contains, that's a pointer to RTL, use thread start, RCX. We've left RBX alone. Let's just let that run. Where are we? Thread preamble is executing. Thread context is... What is that? Thread context is a pointer to something that we don't want it to be. It's none of the values that we've put in here. We've definitely resolved the problem of the thread context by setting, the thread preamble by setting RDX. There's no doubt about that. The interesting thing here is that it's saying that thread context is this. Now, this pointer is a pointer to RTL user thread start, which is not correct. So that would mean that if we restart this, at the time that we've actually just hijacked stuff, that didn't do what I was expecting. Hang on, sorry. Set a breakpoint again. One of these pointers needs to change. Let's figure out which one it is by actually debugging some stuff. Jump racks. Where is RAX being pointed to? Init func. So it's R8. It's got to be R8. Ah, there it is. Check it out. R8 and RDX. Bingo. All right, let's do this. Set R8 to... It's interesting that our thread context has effectively completely disappeared. We actually need to pass thread in here. I wonder why that is. I wonder why R8 gets clobbered by doing this. So we don't have to worry about it in 32-bit land, but in 64-bit land we do. Crazy. Did everyone else see that too? Right there. And we set RAX to whatever RDX is, which is our... Oh, that actually contains the thread context. Yeah, that's interesting. Yeah, that's right. Ah, because we're actually shuffling the... Yeah, okay. Okay, let's see what this does. Just let it run. Thread context succeeded, run. Let's have a look. Created that and thread preamble is executing thread context. Thread context is incorrect still. R8 is null. Did I do something silly? People? Ooh. WinDBG isn't happy. Come on. Talk to me. I might have to restart it. I think it's just crapped itself. I hate harshly shutting down debuggers. I think they're going to do really horrible things to me. Wow, it's not happy about something, hey? I wonder why that is. I've done something dumb. Someone tell me what it is that I've done. Anyone? Everyone's gone really quiet and I've lost a few people. I must be doing something silly. I wonder if RDX is exactly what it is that I need to modify. Let's copy that over again. I haven't like changed IP address or something again, have I? No. Okay, that's better. Maybe it was a dodgy compile or something. BPNT DLL bang RTL user thread start. R8 points to... Where are we? Thread preamble is there. Okay, so R8 contains thread preamble rather than thread. And where is the thread supposed to be? Executing thread. Yeah, I've definitely got the pointers wrong still. So I'm not setting the right thing to the right thing. Okay, why is R9? Yeah, I don't know why R9. I mean, R9... I didn't see that. So R8 should contain thread, and RDX should contain... Hello, what's going on here? That shouldn't be set to that. That should contain Just wait a minute. Base init func move R8 to RCX, which is the first parameter, and that contains our thing, and RDX contains... Seems to be moving things between R8 and R9. Is that just trying to reorder things? So on Windows, RCX and RDX are the first two parameters, and then R8 and R9 are the next two parameters. So I'm kind of seeing, R8 move to RCX and RDX move to RAX. And that then sort of dispatches the call to 1B. Hang on, let's just see. Is that the thread preamble? Thread preamble is, okay, so we're dispatching the thread preamble, but at this time, RCX contains this pointer. And that is not what I was expecting it expecting it to do. Thanks, Lucas. I'm au fait at the moment with the calling convention. I think the problem is that I've just poked the wrong value into the wrong register. Because by the time we get to, where are we? Here. In here. R8. R8 does not contain what I was expecting it to contain. It's a pointer to RTL. That should be pointing to our thread object. Why isn't it? Something's overwritten it prior to coming here. Let's do the restart debug thing again. Sorry. Something's being moved into R8 prior to that call, right? There it is. It's RDX. Okay. So if RDX contains... Or does it? Base thread init func. Uh-huh. It's just pretty gross. I was hoping that this was going to look nicer than what we were doing before, and it's not really looking that much nicer, I'm not going to lie. R8 at this point definitely needs to not be that value. So that means if we're going to set the thread context the way that we're currently setting it, then at the point that the function is invoked, we've set RDX to thread preamble, which according to that is not the case. Oh, this is because we're in RTO user threads. Oh no, that's fine. So why is it that... Ah, okay, I think I get it. We want RAX. We want RAX to point to thread preamble. And we want RDX to have the thread in it. Yeah, I think that's what we need to do. Did you guys see that too? It does seem like alerting RIP before was cleaner. Yeah, but we still had to poke things into the stack. We also had to modify RCX for 64-bit. So we were modifying EIP, which I'm not a huge fan of, or RIP, and we had to modify at least one other register, which, is this worse? I think this is way cleaner in 32-bit land, but the 64-bit land, it's not feeling that great. But I mean, look at the kind of crap that we're doing. It's not. I don't really expect it to be amazing. Ooh, we got an exception that time. Okay, so what have we got here? Right, RTO user thread start. So we've... This can't be what I'm expecting it, because we've just set Rax to thread preamble and RDX to thread, and neither of those things are right. I'm really confused. Why would that be the case? Because when we resume the thread, we should be pointing... We should be hitting this debug break. Right? Is anyone else confused? I feel like there's some magic going on behind the scenes here in 64-bit land where the parameters are being shifted around a little bit in an unexpected way. Wait for that to finish building. Copy over. Can you BP way before the clobbering that's happening in the registers to see more detail? I was kind of hoping that I could, but I'm basically setting a breakpoint at the very first point that the thread is being invoked, so I don't see how I can get to it any earlier. So, as you can see here, our first breakpoint is just before we even try and change the thread context. So the thread's created in a suspended state at this point here, at this breakpoint. So rip points to this, where are we? We've set a breakpoint at this location, and that is RTO user thread start. So if I F5, we actually hit that breakpoint. So that should be when the thread has been resumed, right? And when the thread's resumed, move kernel init thread function RDX, which currently points to RTO user thread start, is pushed into R8. Now that's a value that, according to this, we have modified, which is why I'm confused. We didn't see a set thread context failed, did we? No. Get thread context succeeded. Creating on thread, so the thread has resumed. You can create thread in Win32. Oh, create thread's way too late. I mean, what we're really, yeah, we are. You're a little bit mistaken, mate. But I appreciate your train of thought. The problem that I've got here is, by the time we get to this dispatch call, which calls into this base thread init thunk, you'll see here, this is when it's actually dispatching to the function that we've given it. And the values that we've passed in, RCX contains the wrong value. So 52EA90 should be our preamble, right? Thread preamble there. Oh, 1B 52EA90, what's that? 52E850. I don't see that anywhere, do you? Where is that going? What on earth is that? Did everyone see that? That's really strange. Clear ECX. Jump to base thread init. Move R8. R8 points to thread init start. Why is it that Rax points to that? R8 RCX now points to thread init thunk. Rax points to the thread context. So that's trying to jump into the thread context. Is that what I'm doing wrong? Are they the wrong way around? 4B. Hey ho, iBot. We are hopefully coming to the end of getting a 64-bit version of a sort of thread injection function working that's a little bit more surreptitious than the standard options. I'm confused though, because Rax right now points to the thread, and I was not expecting that. Thread preamble 1B. Don't even know, that's not even anywhere to be seen. Even though we've modified the registers, nowhere to be seen. That's really bizarre. That is not what I expected to see at all. Hey Zorkat, how you going, man? Yeah, this is pretty interesting. Why is this not behaving the way I would expect it to behave? So, okay, I'm just gonna comment these things out again. I would have expected, based on the general premise of how these things work, you give a function an entry point when you specify create thread, and then you give it a thread parameter. When you call create thread, obviously behind the scenes it's calling the RTL user thread start as the entry point, and from there we were thinking of hijacking it, but we don't want to hijack it, we just want to let it run. The difference is that we just want to shift a parameter around. So really what we should be seeing is we should just be able to modify this entry point wherever that happens to be to point it to thread preamble, and we should be okay. So if the entry point I'm going to go back to that very premise and do exactly the same thing again. Don't think you can help. Oh, maybe you can't help. Maybe you could learn something. Maybe you can chime in with an opinion. If Windows low-level C-related bits and pieces is your bag, then maybe you can add some value. It's up to you. Okay, let's try again. Please make sense. I hate it when things don't make sense. Okay. So what I'm thinking of doing is, like, there are these 2 pointers, sorry, 3 pointers, Rax, RDX, and R9, all point to whatever the hell it is that, but basically we're pointing to ourselves. So I think what I'm going to do is just go back here. I'm going to leave RDX alone because I honestly think that's okay. When do you start programming? We're doing it right now. We are doing the programming thing right now. So RCX was the same, and R9 was the same, wasn't it? R9. No, not RCX. Rax and RDX. So that needs to be Rax, RDX. That didn't work as I was hoping. So if I set all 3 of these values, which I'm assuming is going to cause some kind of crap to happen. So I mean, if we look straight away here, RCX it overwrites R9, so I don't need to do R9 because that happens immediately. Ooh. I've got another follower, Senor K, Senior, Senior K. Thanks for following, man. This is as programming gets, as far as I've experienced. Yeah, lots of stumbling, testing, different things that often don't work. That's exactly what it is. And it's messy. So based on what we saw here, we can see R9 is overwritten with RCX straight away. And RCX contains something completely irrelevant. When maybe that was the intent. If is that what you meant to ask? iBot or LBot? I can't see because my font is terrible. Was there a stream before this? Well, we did x86 earlier in this very stream, but we did more shenanigans with this exact thing on Wednesday, so you can look at the archive if you're interested. It's on Vimeo, and I think it might still be on Twitch as well. So if RCX clobbers R9, and RCX currently points to... Is that the thread context? Yep, create a command process thread. Yeah, that's definitely the thread context right there. So that goes into R9, and then Rax gets clobbered with that. So really RDX is the only thing that's left. So now I'm even more confused than I was before. iBot. So the phrase "old mate" is an Australianism. It doesn't mean that you're old. It doesn't mean you're new. It doesn't mean anything like that. It just means it's like a friendly reference to a person you don't know. Old mate over here. It's just like, you know, somebody over here. Okay, Barney, you have a good one, man. You take it easy, all right? Thanks for coming in as always, mate. Yeah, so please don't take that as an insult, iBot. That's not how that's intended to be. It's a bit of slang down our way, but it's meant to be a friendly reference to someone that you don't know. So was that the intent of your question? When did I start programming? Was that the intent? Did you mean like me personally from yonder back, or do you mean today? This project, yes. Okay, so this project is it's a combination of things. The project is the source code we're looking at is something called Meterpreter, which is it's a remote access Trojan that's part of the Metasploit project, and that was originally built by a very smart man called Matt Miller, who goes by the name of Escape, back in like 2007 in cahoots with HD Moore. So this project is way longer than has existed way longer than what you're seeing here. I'm just kind of enhancing it along the way in ways that I see fit to help sort of evade detection in certain scenarios, and that's effectively what this is about. So that's what the Meterpreter project's lifetime has been. The project that we're currently doing, as in why I'm streaming this stuff, is us just trying to bypass some very rudimentary thread injection detection. And we started doing this on Wednesday last week. So hopefully that answers your questions. And I'm just trying to figure out why things are not doing what I would expect them to do. Because here... So I'm still confused as to why we're seeing a reference to the thread context appear in RAX at this location. Like, why would that be the case? I think I'm going to I'm going to have to hijack this in a slightly different way, or perhaps even just leave what we did before. Yeah, that's okay. No problems at all. I appreciate you dropping by. If C's your bag, or any of this kind of stuff is your bag, you may still be able to add some value. But yeah, I think at the point that for 64-bit land, I'm not really seeing any value in doing what we're doing. Hey, let me just quickly run through this one more time, just to get something straight in my head. Set that breakpoint again. Standard stack stuff. R9 that's just persisting RCX. So this is basing that off. Okay, so that's not something that we have control over. We do have control at this point over RDX, RCX, and ECX. RDX, R8, etc. So RDX points to this, basically the parameter that we've given it. So we can hijack that at this point. We can do the same for RCX. But that gets cleared prior to the dispatch. Dispatch contains reference to racks, which is fine because we're not going to hijack that. ECX should at this point always be 0, which means that jump will never be taken. Then we take the content of R8 and we put that in RCX, which is the first parameter. And then we take RDX, which should be the second parameter, and put that in racks. So that means RDX definitely needs to be modified. And R8 needs to contain I'm back to where I was before, hey. RDX needs to be the thread preamble, and R8 needs to be the thread context. Pause debuggers, they always seem to give this strange feeling of something in your clipboard you're supposed to do something with. You have to comment out the return 0 next. I don't think so, because we're not even at that point yet. AppWolf. A lot of the stuff I'm getting on Google is mid-2000 results. Yeah, I don't think it has, eh? Okay, thanks, iBot. Appreciate you dropping in, mate. I'm going to do this again. I'm going to rebuild this with R8. I'm pretty sure that these two should be enough based on what we've just seen. Right? Because what was in R8 gets pushed. Sorry, what was in... Oh, I've got another subscriber. Sorry, follower. iBot's now following. Thank you. Thank you, iBot. New mate. Old mate. We're all mates. We're all mates here. Now, before I copy those new ones over again, let me just quickly, again, follow the trace of what R8 contains. RDX clobbers R8. And RCX clobbers RDX. So D is in R8, C is in RD. 11. So R8 moves to RCX and RDX moves to RX. This actually might make a little bit more sense because yeah, so DX goes in R8. Everyone's your mate, right? That's how it works. Okay, RDX goes into R8. I'm confused. I gotta write this down. RDX into R8. And then RCX into RDX. And that's all we control at this point. We don't give a shit about R9, right? And then we clear RCX. We jump into this, clear RCX, test RCX again. And so R8 goes into RCX. Goes into RCX, which is the first parameter. And then RDX goes into RAX. Well, isn't this interesting? So, if RDX is copied into R8, then this is copied into RCX. Then RDX effectively makes it into RCX and RAX at the point that this call is invoked. So whatever it is that we put in RDX is passed as the first parameter. Okay, so... And that's the thread preamble, or it should be, right? Oh, we've got an exception. What's RDX 42EA9? That looks like the thread. So that's this thing here. Really? Do we have to pass something different in here? Maybe we do. So if we go thread preamble here, instead, maybe that will put the thread preamble somewhere that we need it to be. And all we need to do is figure out where to shove a thread reference for everything to just work. Would that make more sense? Well, obviously we would need to go ahead and fix this. That actually makes a lot more sense. Or does it? This just seems designed to be confusing. Yes, it could also be me. Could very, very well be me. Let's see what happens here. I admit to being a little bit confused. Oh, hang on. Did I actually deploy? I didn't. I ran it again, didn't I? Jeez, I'm dumb. I ran it again to try and understand it, and then I haven't copied the new binaries over. So whatever it was before this is not functioning the way that I would expect. So I don't think this is going to change anything, but it may just clear up some like one thing for me. And right now I'll take anything. So RDX contains a pointer to RTL user thread start, and that goes in R8. CX is a reference to 1BC98, which is the thread preamble. So that's the pointer that we actually want having things overwritten with. Okay, that's the entry point. So R8 goes into RCX, which clobbers the pointer to the function. RDX goes into RAX, which clobbers that gets the same value. So that's going to call the thread preamble. But the value, which is an RCX, is something else. So that makes a little bit more sense. but we still need to figure out how to thread the value through for the thread context itself. Because the thread context right now lives in... where is it? Should be in R8. And it's not. Why is it not? That's definitely our thread context. I can't even see it in any of the registers. I can't see it on the stack. Hang on a minute. Wait up just a second. Just hang on just a minute. Catch me too often to be super frustrated. Chasing down an irrelevant, am I going crazy rabbit hole? I can't do the copy from inside the Windows VM because it's deliberately isolated from the other stuff, so I need to reach into the virtual machine from the Fedora box to the Windows box, not the other way around. I'm just wondering something. So RTL user thread start starts here, right? I'm wondering if when we create the thread suspended, that technically one or two of these instructions has already kicked off. So I'm wondering if instead of setting a breakpoint to breakpoint nt dll bang RTL user thread start, we breakpoint just a few bytes later. 1, 2, 3, 4. So we break on this line instead. And the reason why I'm thinking that is because, like, looking at the stack, where is it? What? Thread preamble is executing. What? No, that's not what I wanted. We want to stop here after the get thread context has succeeded. Get thread context succeeded. Now I want to set a breakpoint to RTL user thread start and go. Okay, that makes a bit more sense. Now what I want to see is the stack, right? So RSP. Okay. Now let me just see this. I'm wondering if, like, when we were debugging previously, it was the second call that we were... probably Lucas. I can't say that she's mentioned it to me anytime recently, but yeah, I wouldn't be surprised. R8 contains 1BC98, which is the thread preamble. RDX points to RTO user thread start, which is exactly what we want, right? Ah, okay. Okay, I get it now. I get it now. So at this point, the two parameters that we expect to see in here is RCX needs to contain a pointer to the preamble, and RDX needs to contain a pointer to the thread. Right? CX and DX at this point. Yes, yes, yes. This makes so much sense. I'm really bummed it's taken me this long to connect the dots. Okay, so what we need to do is... So RDX contains a pointer to the thread preamble. RCX... Yeah, so we're back to what we were doing here, right? RDX goes into R8. Okay, so RDX equals thread preamble. RCX equals... That's RTL user thread start. And there is currently no pointer at all to the thread. Right? And then when we get to this point, we can see that we put whatever's in R8 into RCX and whatever's into RDX into RAX before we call RAX. Okay. And we call RAX. Now remember, we get one invocation to RTL create user thread, and then we're giving it a reference to invoke it again. And all of the parameters need to shift down one. So what I'm thinking we need to do is in here, we need to pass entry point, and we need to pass in thread preamble. And then at a certain point, we need to modify the second value that's passed in to the second RTL create user thread call so that it contains a reference to the thread context. Oh, Christ. I love and hate this debugger. It's definitely breakpoint. Thread preamble. Why is it saying thread preamble is executing? That shouldn't be happening. Get thread context succeeded. Thread preamble is located. Okay, that's fine. Set a breakpoint. So we'll leave it at +4. Go. Okay, that's better. So we don't have any reference at all to what it is that we gave it, which actually makes a lot of sense. Because here, once we're going through this stuff here, right? We call the dispatch. We actually end up dispatching another call to thread start, and that's what we have given it. That is this thing here. We are telling it to invoke that again. Okay? And so the first parameter is legit. We just then need to add a second one. And the second parameter is what gets shoved in RCX. Right? And RCX, as we saw, comes from, is it R8? RCX gets given a value from, we can't modify it there. DX. So that's fine. RDX also goes into rack, so RCX comes from R8. Yeah, this is a problem because R8 is persisted. Yeah, we need to modify RCX. That was it. Oh, Christ. Thread preamble is blah. Breakpoint. Run. No, it's not. It is. It's RDX. This is quite tricky. King Jasper, I'm not currently reversing anything. I'm just trying to hot patch some stuff. Thanks, Exorcat. That's awesome. Appreciate you sending those links. Yeah, this is a real royal pain in the buttis. Because in this context, it's like we can only pass one parameter through and we need to be able to pass two. And we want to be able to... We could somehow maybe find a way of suspending the thread a bit later on, but that's not really great. King Jasper, thank you for the follow. Am I a contributor? Yes, I am a contributor to the Metasploit framework. I am one of the committers to the Metasploit framework and have been working on Metasploit in various ways, both paid and unpaid, since 2013. And the primary thing that I've been working on is Meterpreter. Meterpreter payload was the thing that I kind of dived deep on. And right now, the Meterpreter payload is something that we're trying to enhance slightly. But in 64-bit land, it's currently causing me a bit of pain, which I'm not that happy about, I have to say. So the other option, when you made the last change in VS, did you CP the files back after compiling? Yeah, mate, I'm pretty sure I did. But that doesn't change the content of the code. So is it true that Metasploit never wants to be FUD to prevent the black hats? I'm not quite sure I understand your question there, King Jasper. Is it true that Metasploit never wants to be FUD to prevent the black hats? Can you rephrase that question? FUD, fully undetectable. Ah, okay. Yeah, so you got to remember that the purpose of the Metasploit framework is to be sort of a one-stop shop for like a tool set for security people to sort of build their own things on top of. Out of the box, it provides a fairly standard set of features that you can personally enhance. And yes, out of the box, it doesn't want to be like a state-level rat that can't be detected. That's up to you. But it has the power for you to configure it to be so, should you choose to do that. I hope that answers your question. Yeah, so I'm not sure how we can do this, given that we can't modify the flow of the code in a way that makes a great deal of sense for us, because RCX is something that we've given it. RDX contains what we gave it as the entry point, and we did actually want that to be called again, right? So I'm guessing that what we need to be able to do, I mean, if we, whoops, wrong button. Going back to what I was thinking before, like if we just leave this as thread, I would have thought that modifying RDX so that it just pointed to thread preamble after the fact would have been enough, but clearly it's not. I'm not actually hot patching source here, King Jasper. What I'm trying to do is make a sort of more extensible way of making threads look like they weren't injected illegitimately. So if you want to have get an understanding of what it is that we're actually enhancing, have a look at the stream that we did on Wednesday, where we actually dive into the topic and our first implementation of what I'm actually trying to enhance now. I'm at the point where I'm thinking I'm not going to be able to enhance it, which is a little bit crap. Well, I mean, enhance it in the way that I was hoping to enhance it. So I mean, we can still leave it as it was. You know, the easy option is to just modify rip like we were doing before. I may just be getting my thinking in a twist here. Also had to pop out for a bit. Sorry if I missed something. Why do we need to set the thread entry point back to that if we are immediately going to suspend it and overwrite registers? Okay, so this was the thinking, Smash, and we did actually cover this right at the start. But when you create a new thread, by default, Windows invokes RTL user thread start. What we were doing was creating it suspended, like pointing it to some other function in memory, creating it suspended, and then modifying rip to point to where we want it to be, such as our thread preamble. The problem there is we had to make sure that we had relevant values on the stack so that when the function was invoked, everything was fine in 32-bit land, and in 64-bit land, we needed to make sure that the appropriate values were in the appropriate registers based on the calling convention. And that's what we did at the end of the previous stream. What I was trying to do here was come up with a way of effectively doing the same thing but without modifying rip. Now, in order to avoid modifying rip, what I was hoping to do was pass effectively create a thread that points to RTL user thread start and just modify the argument. So we end up with this double hop, and the RTL user thread start actually gets invoked and it sets all the stack up and everything for us. That was basically the theory. And it comes with the added benefit of if we actually do invoke code directly from RTL user thread start, then if someone is actually analyzing the flow of this code forensically, they can see that RTL user thread start is actually invoked. So it's another sort of step to make it look like it's a legitimate thread when it may not actually be a legitimate thread. I hope that makes sense. Yeah, so I'm in a world of pain here because I want to be able to specify three things. I want to specify not saying to change rip away from RTL's thread start, saying change racks. Well, the problem with changing racks is that it gets overwritten anyway. It's not something we have control over. So if you see here, racks gets clobbered. So we are suspended at this point, but racks is overwritten by something that we don't control. Then again, it did break earlier, didn't it? Let's do a quick test. Do any registers contain the entry point? No. We've only got control over one. But even if they do contain, both, the problem is that the code flow that we see here, RDX, which is the thread preamble that we give it here, ends up going into R8, right? And RCX, which contains RTL, the user thread start, goes into RDX. RAX comes back out into RCX, which clobbers RCX with thread preamble, and then it calls racks, which is RTL user thread start. So we don't end up with any thread-related context coming through. Thanks for coming in, Slickers. Peace. Thanks again. Always appreciate you coming in. So yeah, modification of these registers doesn't seem to be doing me any favors. But let's see, like, based on what we saw here, when we create this thread, racks at this point just gets clobbered with whatever that says. But I wonder if that's in some way reference to it. You know what I mean? So confusing. I feel like I've seen the same thing like over and over and over again. Ooh, what have I done? Macro redefinition? What? That's, oh yeah, okay, that's for WinPML. Let's make sure we've got the latest here. Okay, so you see we've got our 41414141 here. Smash. But then it just gets overwritten with something else anyway. Could the fact that you're setting the entry point to be causing issues where it's overriding something and then an entry point wouldn't? I don't think so, because it's effectively then just a recursive call. The problem is that when we invoke it, we're saying please pass in RTL user thread start and give it the thread preamble, which is actually where we want the thread to start. And that works. But what we effectively need is another parameter to be passed in so that thread preamble becomes the function that's invoked and the parameter that we give it gets passed in. But this is what I'm trying to decipher here, right? So if we go through this piece of code here, you'll see we end up getting to this call dword pointer. Right, so right here, we call RTL user thread start again. So this is the recursive call, right? And then RDX, which contains a pointer back to itself. We've got R8, which references RCX, R8, and R9, which all point to the entry point, right? So when we come in here again, you'll see we should be able to get to this dispatch. And here we go. We're now invoking the preamble. But RCX, which is the first parameter to the function, contains a pointer to RTL thread user func something or other. So we need to be able to control that value at that time, which I can't see how we're going to do. So that's why I was thinking what would be great is if we change this back to thread and just hijack the entry point. But then we're effectively back in the land of we should just modify RIP. We should just modify RIP instead. So what we should do is just say, instead of that, set RIP to thread preamble and set RCX to the thread pointer, which effectively is pretty much exactly what we were doing before. But I can't see, based on the x64 implementation of this, of how I can do this any better. Can you control that value from inside thread preamble? No, because we don't have a reference to it at that point. Why are you not a fan of setting RIP? It's not so much that I wasn't a fan of setting RIP. I'm happy to go with whatever works, but I liked the idea of actually letting the RTL user thread start function run. That's what I liked. I thought that was nice, because then if you look at the call stack, if you look at the process that everything goes through, you can actually see RTL user thread start being invoked from a forensics perspective. So that would make the thread actually look more legit. Yeah, exactly that. Whereas like doing what I'm about to do now, pointing at thread preamble and just setting RCX to the thread, I'm sure this is just going to work. But from a forensics point of view, it's a bit more dodgy. It's just a shame that we're not going to be able to do it in 64-bit mode. So let's just do this breakpoint again. Alright, so this time around, you'll see that when we go into the dispatch, at this point, we'll be going straight, instead of calling RTL user thread again, we're going straight into our payload, back into there you go. It's just going to continue to work now. So if I just remove this breakpoint here, let's comment it out so that it's still in there. This is exactly what we had before. So I mean, what we could do is have the best of both worlds, I guess. I mean, from what I can see, there was no way of creating a suspended thread pointing to RTL create, so RTL user thread start in 64-bit mode, and being able to modify the contents of the thread context and have it do exactly what we want to do while maintaining RTL user thread start as the code path. Whereas in 32-bit, clearly we can just by modifying EAX. The concern that I have with the EAX approach here is that that's probably not as cross-platform friendly. Does that make sense? I feel like we've kind of come full circle and we've come back, at least in part, to where we were before. This method on 32-bit to me doesn't seem as portable. So I may end up sort of just sticking with what I had before. But I'll just copy this over and we'll validate that the thing actually functions as expected. Ready? There it goes. Yep, so that's all fine. Yeah, okay, so I don't know, I'm kind of upset about it, but I think that's pretty much all we're going to be able to do. I was really hoping to be able to leave RTL user thread start in there, but I can't see how we can do that. It just doesn't seem to be flying the way I want it to fly. I would have thought that I could have modified a couple of parameters here, RCX, etc. But yeah, I don't know why it's not. Because when I set RDX, hang on, just bear with me one more time. We set that RTL user thread start. Where are we? That's not what I wanted to do. Maybe my misunderstanding was still on the last stream we did tell this thread to start at legit start address and then immediately. Yes, that's right. Yeah, that's exactly what I've been trying to do, Smash, and it doesn't seem to be working that way. We have been exactly there. Because you would assume that RCX, I don't even know what that points to there. We're not even anywhere near the code that we should be running. Oh yeah, we are. Yeah, we are. We should be running this in a... Oh, that's executing inline. Why is that executing inline? Don't know. But yeah. Oh yeah, that's never going to set up, that's not going to hit the breakpoint because of this. So I would have thought that setting RCX and RDX so that it does its thing would be fine, but that's not what it was doing. And I'm really confused as to why that was the case. Because RDX was the value that was being used to invoke, so we were able to control the flow, but we were unable to control RCX at the same time because of code flow that was basically doubling up values. Like I said, this stuff here, where we ended up passing the same value. RAX was coming from RDX, and RDX was going into R8, and R8 was clobbering RCX, so we ended up with the pointer that we were invoking being passed into the thing that we were invoking. So we just can't, from what I can tell, we can't control the code well enough, and I'm kind of confused by that. But it is what it is. I mean, you know what we could do just for the sake of testing? We could do this. Why did I do that? We could say, because you would assume that if we leave rip as is, if we set RCX, which is the first parameter, to thread preamble, and RDX to thread, that would do exactly what you would expect. But this is under the assumption that we know what the parameters are that are being passed to RTL user thread start. RTL user thread start. Hang on. Is that what it is? RTL user thread start. So debugging blah. I want to know what the signature for this function is. Let's just see if we can dig it up somewhere. RTL user thread start function signature. Yeah. I'm still not quite getting the double entering of... Yeah, I know. This is we're now going over the same ground again. I was trying not to do the double entry of RTL user thread start in this context, but I can't do that because I can only control one value based on the code flow. So I'm trying to see, where are we? Thread start address. Okay, so that doesn't really give us any information on how and what that is. Difference to them, what's there? Context addressers. Okay, so that's doing something very similar to what we're talking about. We've just been there. Does anyone happen to have a reference that is going to give us the function signature for RTL user thread start? I think in order to convince you, Smash, I'm going to have to run this. But this is what I had done earlier. And RDX, based on the code flow here, RDX ends up in R8. R8 clobbers RCX. So we doubled it up. Thank you. There you go. So RTL user thread start is exactly the same. Thank you very much for that reference. That's super handy. Okay, so did we compile that? We did, didn't we? Did that just work? This music is pretty good, isn't it? Yeah, that did work, Smash. And what I'm really confused about is why. Because we were playing with these parameters earlier on. Clearly I missed something. Oops. Oh, there you go. That did actually work. Yeah, so maybe it was the second hop that was causing that clobbering of the registers. No, it's not. Yeah. I mean, that's effectively what we were trying to do. Hang on a minute. So with this in theory, if that's the first parameter, so we're calling this with this, and what we want to be able to do is only modify this. So if we change this thread, we should actually be able to get rid of that. Does that make sense? RDX is preamble. Yeah, okay, that's probably what I did wrong then. Because this RDX value should already be in RDX based on the fact that we passed it there. Right? Let's show you, no matter how many times and how long you stare at the problem, you can still make really stupid mistakes. This seems reasonable though, right? I shouldn't actually have to set RDX here because that should set RDX for me. Right? What's the bet this doesn't work? Aren't you deliberately not touching? Yeah, I think so. Well, there you go. This here doesn't phase me as much as this 32-bit version. Like, that seems to be okay because we're literally just poking a value in, whereas this, I'm not so sure I like it. It might actually be... I just wonder if that's platform specific or... Oh, actually, hang on. I wonder if that's because maybe RTL user thread start in 32-bit has a fast call. Now let's see what NT-sys API void NT API RTL user thread start. Okay, so it wouldn't be fast call because it doesn't look like it has that. Unless NT-sys API is implicitly fast call. Does anyone know the answer to that? NT-sys API. Excuse me. Okay. Yeah, so it'd be nice to know what this is. I'm tempted to... Let's just check in this repository to see where it's defined. Is there a define somewhere? Yeah. Here we go. Nope. I want to see where this is defined. And it's just default spec. So the reason why I'm diving into this, by the way, is because I'm really keen to see whether or not NT-sys API is fast call, and whether or not that is why we're seeing the value that we're poking in EAX instead. Define decal spec. Okay, so that doesn't mean anything. Through some breakpoints, through 6 Win7. It looks like EAX and EBX. Yeah, that's exactly what I thought too. So I just want to know if this is it, because you would assume that it would be on the stack, right? That would make the most sense. So fast call goes ECX and EDX, so that's not it at all. I wonder why. I wonder why EAX and EDX are used. RTO user thread start on x86. So that's exactly what I was seeing as well, Smash. So that's why in the code here we are only poking EAX, because this obviously contains a reference. Interesting, huh? Okay, so that was like 2.5 hours of circling around, which is never a great deal of fun. But what we can do now, I mean, we can... Yeah, NT-API standard call, that's what I thought. Thank you for auto. And that doesn't surprise me because, I mean, just looking at the documentation there for fast call, saying that if you specify something in 32-bit fast call, you end up with ECX and EDX registers being used. So it doesn't use EAX and it doesn't use EAX and EBX like what we're seeing with the RTL user thread start function, which is very interesting. So as I said, there's 2.5 hours of going around in a circle to try and make things a little bit better, and I think, you know, the end result here might be slightly better. I'm still kind of concerned about this in 32-bit land, but it is what it is, right? But there is one thing that I'm finding interesting. Actually, what I might do is, let's just get rid of this. Now I'm going to assume this is going to break. Uses the address of the actual image entry point, and the start parameter calls the application's entry point. These two parameters have also already been pushed onto the stack by the kernel. So they're on the stack as well. I wonder if there is something somewhere that assumes that those values will be on the stack in this scenario as well. Probably not, given that we control this scenario, right? Now I'm expecting this to break horribly. Why didn't that break? Because that breaks in 32-bit, right? So we have a working session on 64-bit when we remove all of this nonsense. But in 32-bit, when we just set EAX, it dies. Right? God, I hate the compile errors that we get in this now. Just going to do this again. Copy over. Restart. Yep, that works fine. Okay, let's just do another quick test of this on 32-bit. And 32. Clean. You have to clean and rebuild this because it gets its knickers in a knot when you don't. So again, sorry about the wait. I should read. I've got that exact book, Smash. I've got that exact book. And I should open it and have a look at that. Share user thread start. This is interesting. So, given the behavior that we've just seen in 64-bit land, you would assume that there'd be some similar behavior in 32-bit, but I'm guessing it's not going to be the case. Physical books need a search function. They have one, but it's slow and manual. Can't believe it's 10:30 already. We've still got a few warnings to get rid of in this code. But most of it's in third-party code, such as the Python extension. Yeah, so 11:30 according to my VM clock, which is in Sydney time. 11:30 p.m. Pink Tangent, you are here. Lovely to see you. Yeah, Sydney time or Melbourne time, 11:32. On my desktop, which you guys can't see, it's 10:32 because for some reason Queensland wants to be a jerk and not be in line with the rest of the East Coast. But let's not have the daylight savings thing kick off on stream. No one wants to have that argument. Good evening, Pintangent. I hope you're well, mate. I appreciate you coming along. We've done a very big full circle here. It's been a little bit disappointing. Clearly I'm stupid. This stream has proved how stupid I can be. It's a wonder anything works. So this time we will need a 32-bit debugger. And we'll be opening payload. And before we let it kick off, we'll just, oh man, I should have had more ones earlier. That was really good. Okay, let's copy the 32-bit ones over. Okay. And, okay, let's have a wager. Who thinks this is going to die? Anyone? There you go, Lucas with the hands up. I think this is going to die. We did see it die before, right? It's not dying. It actually makes sense. It actually makes sense that it doesn't die. I just don't understand why it didn't die earlier. Hello! I need to get close to be able to read the name. Is that Hinamore or Hinamore? Welcome to you. Thank you for coming on the stream. Yeah. That's both upsetting and just Hina. Hina. I'm doing very well, thank you, Hina. How are you? Whereabouts are you based? There you go, works perfectly. Crazy town. Now, that's 2.5 hours of a lot of fluffing around. Pretty good, you're from the UK. I was born in the UK. The motherland. Country's terrible. Well, we left for a very good reason, and I'm glad that we did. Maybe you changed something else in the flow that fixed it. Yeah, so I mean, it makes, when we look at it purely from a theoretical standpoint, if we suspend the thread on start and we just modify the first value so that it points to our thread entry point, everything should work, right? Everything should work as is, because you would assume that the RTL user thread start function would go through and do all the management of the stuff that needs to go on the stack and terminating threads and all that other nonsense for us. Yeah, that makes a lot more sense. Hina, at the moment you're looking at me fumbling terribly, but we've just we've got to a point where we're able to evade the detection of injected threads by making sure that every thread that we create in our context is pointing at this RTL user thread start, where we just end up hijacking a couple of arguments after the thread's been invoked, and off it goes. And that basically means that some tools that rely on detection of injected threads having their base addresses pointing into areas that aren't marked as mem image will no longer be able to do what they claim to be able to do, because every single thread will have that flag applied. If that doesn't make a lot of sense, then I would recommend maybe looking at the previous stream where we dive into that a little bit more. We're just trying to enhance it a little bit, and I think we maybe have ended up with a slight enhancement, but I feel like an idiot. You sure? It's still... Should we check? Let's check. Let's fire up PowerShell. Actually, I should... Probably don't need to do this as admin, do I? IX new object system.net web client download string. Let's see. I can't see one. Did I kill it? Maybe I did. Okay, so it's running now. Yep, there you go. Still happy. Which does make sense. However... Whoops. Migrate. Actually, maybe I shouldn't do Explorer. I've got a notepad open. Let's use notepad. Migrate 4280. So, this should give us an injected thread now. There you go. Which isn't surprising, yeah? That makes a lot of sense. So, here's the thing. Migration is obviously a different beast. So, let's just exit out of that. Now, I can show you quickly. For those that are interested, there should be a function in here. Create remote thread. Now, create remote thread is used only in a subset of contexts. Okay. And basically what it's saying is go and create a thread in another process, etc. It's actually quite a complex beast because it's wrapping up multiple ways of creating threads in a remote process. The one that we're mostly interested in here would be create remote thread, which as you can see is invoked. Well, you can see it's have another follower. Thank you, Mr. 64-bit, for following. There are a few cases where in the code create remote thread is called directly. But we're interested only in the spot where Meterpreter uses it during migration. Here we go. So, you can see here, we are calling create remote thread in a given process. Now this is going to be invoked when we do migration. Or at least it should be, right? So there should be a core migrate. Request core migrate. So as you can see, we get a bunch of stuff out of the TLV packets. And another follower. Thank you, Eva Vactress 29. Did you know about Ghidra? Yes, we were going to have a chat about that towards the end of the stream actually, but we haven't quite got there yet. So, I want to have a look at here. You can see that we are. This is a lot of accounting nonsense, but eventually we're going to get to a point where we try to create a remote thread. Here we go. Inject via remote thread. First we try to migrate directly by creating a remote thread in the target process. If that fails, we then do the APC thread thing. So let's see what inject via remote thread does. See how it calls create remote thread. And it creates it suspended. So the theory here is we want to be able to set LP start address to something else. you might want to take a look at that new method called atom bombing. Yeah. So atom bombing isn't something that's necessarily going to work for us too well in this particular context, and that's partly because it adds complexity. It's got various limitations, and it's just another way of actually getting data moved over to another process, right? But it's not something that I think would fit in the case of Meterpreter's migration. Plus, it's kind of beyond the scope of this particular stream. We could dive into that another time if you wanted to see how atom bombing actually works. But it's something that I pondered putting into Meterp as an option, but at the end of the day, it's not really that much better or worse than what we currently have. This is not actually chocolate, these are just almonds. I'm being a good boy tonight. Sorry about the crunch, I should be more aware of the fact that I have a microphone right in front of my mouth. Now, so see this is a really important thing to note. When you try and create a remote thread, so threads in another process, if you're in 32-bit and the process you're trying to inject into is 64-bit, this won't work. And so there's this whole magic inject via remote thread WOW64, which behind the scenes transitions the thread from 32-bit to 64-bit and then invokes a create thread function inside like WOW CPU.dll or something similar. So there's a bit of magic involved when you go from 32 to 64-bit. When you go the other way, it's fine. When you go from 32 to 32, it's fine. When you go to 64 to 64, it's fine. It's just 32 to 64 that you have to do some horrible stuff. Excuse me. So we can look into fixing it for 32 to 32. The problem that we've got is that when we create this remote thread, we need to be able to read a remote process and get references to, for example, things like RTL user thread start, so that we can put that address in, and then when we create the thread suspended, we can then do the thread context stuff like we did before, right? 425. Yep, that code comment has probably been there for a very long time, Lucas. So what I think we're going to do, given that it's been 2 hours and 45 minutes, and I know it hasn't been that constructive, but it's been fun. I've had a bit of fun. I think what I should do is stop the stream there, because there's quite a bit more. Thanks for following, Hina. That's really nice of you. I think if we stop here because we've gone for long enough, that would be good, and then maybe in a few days we can come back to this exact line of code that we can see here, and we can start fixing the issue in cases where the architecture matches, and then from there we can come up with a method for fixing the 32-bit to 64-bit version. Now there'll be dragons in there, I think, because if we're creating threads remotely, then we need to know the start address of RTL user start thread remotely. So we actually need to be able to probe a remote process to figure out where that is. And I, off the top of my head, don't know how to do that. So we're all in for some learning. So anyway, it might be messy, but once you migrate into another process, could you then create a new thread and move to that? Yeah, that's actually one idea that you could have. So your migration stub, the first thing that you do is resolve that function and create a new thread that goes there and then terminate your current thread. That's actually a really good idea. The problem with that, it's not really a problem per se. You would only do that in cases where you know you were able to successfully create a remote thread. And you wouldn't employ that stub in cases where you were doing things like queue user ABCs or ABC thread hijacking, for example. Yeah, that's a really good idea, Atwolf. Because, I mean, at the end of the day, the thread has to be active at the time that the scripts run, right? But there could be EDR tools that actually pause threads and analyze them before they actually kick off, etc. So it would be nice if we could actually create every thread in that way. I'm sure there is a way of doing it. I'm sure there would be a way of us saying, give us the process address of something remotely. So we can explore that, figure out how to do it ourselves, and maybe implement that in a few days' time. I've never understood migrating from 32 to 64. It would be good to learn more about that in future. Yeah, well, I mean, if you guys are interested in having this stuff work on migration, then we can dive into exactly that, because we will need to cater for that case. So I'm happy to show how migration works as it currently stands before we move on to implementing something that will bypass thread injection detection when migrating. All right, cool. Let's do that. All right, so I don't know when that'll happen. I'd like to think it'd be Wednesday or Thursday this week. It just depends on commitments. I know I've got to go on site for a couple of days, which will no doubt make me not feel like streaming when I get home. But we'll see how we go. Let's pencil it in for later this week. I'm also actually interested in trying to get Twitch affiliate status, so I'd like to stream a little bit more if you guys are interested in playing along with me. So there you go. More of these streams, you get Twitch affiliate, just like you said. All right. I'm going to love you and leave you. Thank you very much to everyone who's come along and contributed and had a chat and offered insights, and Smash for pointing out just how stupid I am. Because, you know, earlier on in this stream I swear I did that, but clearly I didn't, because that's not how computers work. It was clearly me that was doing something stupid. Mr. 64-bit, thanks very much for coming along for however long you were able to do it for. So I'd like to see some Linux kernel exploitation bypassing SMEP. You know what we need to do is you guys need to hit me up on the various internets, offer suggestions, and I'm sure we'll prioritize what we can do so that everyone gets a taste of the things that they're interested in doing. I'd be happy to dive into whatever else it is that you guys want to do. I would like to wrap this up though, because I think this has been an interesting little pursuit. So this will be what's on next, but whatever we do after that is totally up for grabs. Thank you all. You're all awesome. I love your support, and I'm really grateful as always that you come along and have a laugh with me. Behave yourselves, and I'll see you again very soon. Ciao.